In this video, we're going to be doing an example of a laser, plasma, or water jet job. Now, they all kind of work the same way. It really just depends on what type of machine you pick inside of BobCAD. So I'm going to do this as a water jet. So I'm going to right-click on my CAM defaults and say New Job. Now, we still use milling for this, but when we pick the machine, I'm going to go ahead and use my BC3X water jet right here. So when we pick the machine, that defines really what tool we're using. And when you're doing this, you really only have one tool path that you're going to use because you don't usually do rough and finish passes on a laser, a plasma, or a water jet. So I'm just going to go into the stock wizard and create the stock for this. So the workpiece, again, is always looking for a solid model, so I don't have anything there. But right here, I could choose my rectangular stock. So I'm going to set it up as 48 by 48, and then for the thickness, I'll go with just a 1/4 inch thick. Now right down here, we'll see the origin, and if I actually zoom in on the corner here, we'll see we're a skosh off right there and right there. Just a little bit. So what I want to do is tell it that the center of the stock is actually at 24 and 24, and that's going to square me up in the corner because this is the corner I'm calling my origin, and that's where I want all the code to be based off of. And that's why I drew the whole part in this upper right-hand quadrant. If you choose on your machine this corner here or this corner here, you would just draw it so that corner or that corner or that corner is at XYZ0 and your parts are in the different quadrants. So I'll go ahead and hit next, and then the reason we set it all up like that is because now that corner, by default, is the selected corner. So I'm just going to go ahead and say Z. I'll lift it up just a 1/4 inch, and then for my clearance plane, I'm going to leave it at 0 and hit OK. Now if I go back to a top view, there's all the geometry. Now the toolpath that we use is a very simple toolpath. It's a profile finish. So I'm going to right-click on Machine Setup 1, go down to Mill 2 Axis, and I'm going to select my geometry. Now the geometry for this is all of these parts right here. Now while I'm here, we also have to set up start points for all of these. So we need to make sure that we have our start points in areas that aren't going to collide with other pieces of geometry, which we could have happen. So what we could start by doing is saying, I want to start in the middle of the longest entity. And then hopefully, with the size of the water jet, the laser, or the plasma, we should have enough space even for our little leads to come in and cut. Now, the total depth really doesn't matter when you're doing this because you're always going through the entire part. So I just have to set it to the depth, hit OK. If I wanted to leave it at a 1/2 inch, that would have been fine too. There's all my parts. There's my total depth. We're not going to change the clearance, rapid, or feed planes. Those are just above this flat sheet of material. And then we're not doing extensions. Extensions are primarily for open shapes where you want to extend past the edges. For the strategy, though, we have by default a profile rough and a profile finish. I'm just going to click the profile rough and then hit this little red X to leave just the profile finish. Next, again, we have our tabs. Now, this would be useful if we didn't want these parts to fall after they've been cut. You could go in and leave tabs on the part. You do have to make sure your post has on-off commands for the tabs built into it, but all you'd really define on this is the width of the tab that you're trying to leave. Next, again, we have our posting. No changes to the work offset. We're using work offset 1. A lot of these machines don't even use work offsets. And then right here, the contour ramping output does not apply to this job because this is not contour ramping. We're not ramping down into the part at all. We're at a set level and either blowing water, plasma, or a laser through the material. So for the water jet tool, we just have to define the diameter of the cut. This is the kerf of that nozzle that you have on there. So for this one, I'll just say it's 80 thou. And then right here, I'm going to set up the diameter just so it shows up right if I see it anywhere else. The cutter, you can choose whether it's on or off. Your abrasive can be on or off, and then whether or not you're running your vacuum assist. And then right here, you just enter in your feed rate, your pierce dwell time in seconds, and then your pressure type of high, medium, or low. If you don't have to set this stuff up, because some machines you don't have to put this in, you'll enter all this at the machine. You can just leave this blank, and the post itself will just not output that because the machine will tell it what to do. But for me, I'll go ahead and say that the feed rate is 20 and the pierced well is just 1 second for now. Next, we have our patterns. So for the compensations, we either have system or machine. Now by default, I like to leave it on left. The problem is when we pick geometry, this left is based on the direction that's chosen for the cut. So if we compute this and we see toolpath on the inside of the part, it means we need to reverse the direction that we're cutting in. It's very simple, but again, if we don't have to change it, you could also potentially go to the right. You don't have a tool that's spinning when you're cutting with one of these machines. So going to the left or going to the right doesn't hurt too much. So if you go to the right, there's a chance you won't have to reverse directions. But I'll leave it on left, go next. For the parameters, we're not leaving any allowance, and we're taking it in a single pass. So we'll go next again. For the leads, I'm just going to go with little right angle leads, and I'm going to make them about the size of my tool if I can. So I'm going to say 0.08. Because that should hopefully be enough kerf away from the part that when I cut in, I'm not blowing out any of the area I'm trying to save. So I'll go next. For the corner types, really no changes here. It's not something I've used much. Maybe if you want to round corners or do a loop radius in a corner. But for the most part, leave everything on sharp and it's just going to follow the geometry. For the machine sequencing, I always like to use optimized, but you have closest and X and Y direction. Now, no sorting is if you want to cut this in a very specific order. This is very helpful when you're using something like a plasma that's going to build a lot of heat into the part. What this allows you to do is sort it so that you could kind of jump around your part a little bit and distribute that heat more evenly. You could say, I want to do this one, then this one, then this one, then move around that way. And the no sorting is going to do that in the order that you pick them in. But I'm just going to go with optimized, hit next again, and then we just have our advanced feeds. So I'm not changing anything else. There's no corner slowdown I'm going to use on here. Just going to hit compute. Now what we're looking for is the toolpath on the inside or the outside. And if we look around, it's on the wrong side. So what I could do is either go into my feature and switch the pattern from left to right. So I could go ahead and hit compute on that. And we'll see now we're on the correct side. Or I could have gone and reversed the direction. And you can reverse the direction just by right-clicking on where it says default change start point and then just reverse direction. It'll flip the direction. So if I recompute now, I'll be on the wrong side once again because I'm going to the right now. When I'm doing these jobs, I prefer it to go to the right because that's usually the direction that comes out correct within the first try. And the reason that's important to me is because if I'm doing a job like this, depending on feeds and speeds and how I set all that up, that could either be done at the machine or it could be done here in BobCAD, depending on what type of machine you have. The thing is, the path that I need to follow doesn't change between this job or the next job or the job after that. It's all the same. The only thing that might change is the thickness of the material and the shape of the part, which is fine. So what I do with these laser, plasma, and Waterjet jobs is after I get a job done, say for a 1/4 inch, and I have all my feeds and speeds figured out and everything's ready to go, what I do is I right-click on my feature and I say Save Feature. So I'm going to go ahead and name this 1/4 deep Waterjet profile. And then I'm going to hit save. Now why that's very cool. So if I go in here and I restart the entire job, so I'm going to delete the entire milling job. After I have my part drawn, now to do my tool pathing, all I have to do is start my job, pick my machine right there, and go to the stock wizard. So I'll create the same exact stock I made before, which is 48 by 48 by a 1/4 inch. And then I'm going to make sure to center it the right way. So I'm going to go 24 by 24. And that's just moving this center location to the center of 48 by 48. Go next. Origin is at the bottom left-hand corner already. So I'll hit OK. Now what I could do is right-click on Machine Setup 1. And instead of creating that whole feature again, I could say Load Feature, bring in that Waterjet profile, And it'll ask if I want to use the same top and depth. I'll say yes. And then for the geometry, I just right click, say reselect, drag a box over the whole thing. Once again, I'm going to say middle of longest entity, okay, and then I'll just compute that toolpath. And since I have it set inside the feature on the patterns page to right, it usually gets it right the first time. So it'll have everything on the outside. So it makes the job the second time a lot faster. And if you have to change feeds and speeds because of the thickness of the material, what you could do is just save a new feature after you've set it up for a different gauge of material. So now that that's all done, I'm just going to do a save as. I'm going to choose the finished part file here. And then I'm going to start my simulation so we can actually see what this is going to look like. And we can actually remove the excess stock that's going to be sitting around it. So you'll see it looks just like an end mill. It looks like all the rest of the features we do, but it is a little blue water jet here. The plasma will show up red. And we'll hit play and let it run. Now beware that the quality of the job is going to be low quality while it's running bigger sheets of material, just because it's a lot more information that it has to load in. So don't focus on the quality right now while it's cutting. It might look pretty jagged and pretty ugly, but when it's all done, it will look clean. So we'll let that run its way around, filling in these spots. And this toolpath would work with just a one-off part if you were just trying to make one thing. Or like this here, it's a nested sheet of parts. It'll work for that as well. There it is. Now again, to get rid of the stock that's between all these parts that's still all connected, what we could do is on the Measure tab, we go to Remove Chips, Select Chips. We're going to hover our mouse over an area that's going to clear out the rest of it. And you just click on it with your middle mouse wheel, and eventually it will clear out everything on the inside, and that's all the parts we're going to be left with. When we're all done, we can close out. And then the last step would be posting. So first you want to make sure under the machine you have the correct post processor. And then I'm just either going to click this button here to post or the big button up top that says post. And there is my code right there. And from here we could either right click and say save as, bring it right out to the machine on a flash drive, or we can go to the NC editor, make changes, as well as send it to the machine via an RS-232 cable. And that concludes the video on an example of lasers, plasmas, and water jets inside of BobCAD-CAM.